A physicist discovered that from your perspective, you might be impossible to kill. The math checks out. The implications are so disturbing he refuses to discuss them publicly, and if he's right, you've already died countless times. You're just not aware of those timelines. The thought experiment that broke a physicist's mind. A physicist discovered that you might be impossible to kill from your perspective, at least. The math checks out. The implications are so disturbing he refuses to discuss them publicly, and if he's right, you've already died countless times, you're just not aware of those timelines. In 1987, Hans Moravec described this thought experiment. Put yourself in front of a gun connected to a quantum device. Pull the trigger. The setup is simple. Wire a firearm to a machine that measures particle spin. Spin up, the gun fires. Spin down, it clicks empty. 50-50 odds, pure quantum chance. From everyone else's perspective, you pull the trigger and half the time, you're gone. But from your perspective, you only ever experience the outcome where the gun doesn't fire. When that particle's spin is measured, the universe splits. In one branch, the gun fires. In another, it doesn't. Your consciousness only follows the branch where you survive. Pull the trigger 1,000 times. Each time, you hear a click. Observers watch in disbelief as you survive impossible odds, but you just keep experiencing clicks. This is quantum suicide. The implication is called quantum immortality. If consciousness can only flow down branches where the observer exists, then from your perspective, you can never experience your own non-existence. You'll always find yourself in the timeline where you survived. It means that from your point of view, you might be functionally unkillable, not in the physical sense others observe, but in the only sense that matters to you, your conscious experience. But everyone you love doesn't get the same protection. You watch them perish while you inexplicably survive. You grow impossibly old while the world follows normal probability. Moravec eventually stopped discussing this publicly. The quantum mechanics underlying it is real, tested, and verified worldwide. And if consciousness is the observer, the conclusion might be unavoidable. You might never experience the end. That thought experiment has a name, and a man who understood it too well. Hugh Everett's universe-splitting nightmare. Hugh Everett proposed the many worlds interpretation in 1957. By the 1970s, he was drinking heavily and refused to talk about physics. His life ended at 51, and his daughter later took her own life, leaving a note that said she was going to a parallel universe to be with him. Everett's thesis solved quantum mechanics' measurement paradox. Traditional interpretation says quantum systems collapse when observed. But who counts as an observer? Everett proposed, what if there is no collapse? What if every quantum possibility happens in separate branches? When a particle can spin up or down, the universe splits. Both are real, both continue independently. The physics community ridiculed it. Everett left academia entirely. But if every quantum event creates a branch, and events happen trillions of times per second, reality constantly splinters. And if consciousness continues down every branch where the observer exists, there's always a branch where you survive. Everett understood this. His later life suggests unbearable weight. He drank excessively and refused to engage with physicists. Friends described him as deeply depressed. His daughter Elizabeth grew up in the shadow of his quantum multiverse. When Everett passed in 1982, she struggled profoundly. In 1996, Elizabeth took her own life. Her note, she wanted to go to a parallel universe to be with her father. She believed that in some branch he was still there. The scientific community eventually embraced many worlds. By the 2000s, it became a leading framework. Everett's genius is recognized. But the human cost remains. A father crushed by his theory's implications. A daughter who tried to reach another universe. A family torn apart by equations that say all families are simultaneously torn apart and whole. The math is beautiful. But in this branch, his theory reads like a curse. If many worlds destroyed Everett's family, at least one physicist tried to warn others. Max Tegmark's warning to never test. This MIT physicist Max Tegmark published a paper in 1998 with an urgent warning: do not test this. Never put yourself in a quantum suicide scenario. Because if the theory is right, you'll spend eternity watching everyone you love perish while you inexplicably survive. Tegmark is a professor at MIT with impeccable credentials. When someone of his caliber warns you, listen. His paper carefully lays out many worlds and its implications. Buried in the discussion is a passage that reads like a desperate plea. Testing quantum immortality is uniquely dangerous because you can't report back. From the outside, you're just another statistic. From the inside, you're trapped in increasingly improbable survivals. Imagine someone testing this. From their perspective, the device fails every time, so they try again. Each time, they're funneled into lower probability branches. Meanwhile, in most branches, their loved ones are grieving. Wait, it gets worse. In 2006, an anonymous post appeared on a physics forum. The user described attempting quantum suicide experiments 17 times. Each failed. Their final post: "I can't stop existing, and I can't prove it to anyone. Every timeline where I could tell you this happened, I'm already gone. You're reading the words of someone trapped in the only branch where I'm still here. I don't know what to do." The account went silent. No one knows if they stopped, or if they're still out there piling up impossible survivals in a branch we'll never observe. If quantum immortality is real, testing it condemns your consciousness to watching everyone age and perish while you remain inexplicably preserved. Most physicists avoid this topic. Tegmark addressed it, then told everyone to stay away. Because some experiments, once started, might never end. But Tegmark's warning assumes you have a choice. What if consciousness itself is the trap? The quantum Zeno effect. When observation freezes reality. Quantum mechanics has a proven phenomenon. If you observe a quantum system constantly, it stops evolving. It's called the quantum Zeno effect. Now ask yourself, what if consciousness is the observer? What if being aware constantly observes your own quantum state, making it impossible for that observation to end? In 1977, physicists showed mathematically that continuous measurement prevents quantum systems from evolving. The act of observing freezes them in place. In 1989, researchers trapped beryllium ions and measured them repeatedly. The more frequently they measured, the slower the evolution. With continuous observation, evolution stopped entirely. The physics is straightforward. Particles exist in superposition until measured. Measurement collapses superposition. Measure again immediately, you find the same state. Keep measuring, the system is pinned. Now scale this up. Your brain is a quantum system made of particles following quantum rules. Consciousness involves observation, constant observation. You observe your thoughts, your sensations, your observations. A recursive loop that never stops. If consciousness is observation, and observation prevents state change, what happens when consciousness observes itself? Does being aware prevent awareness from transitioning to non-awareness? A patient under anesthesia once reported feeling conscious the entire surgery but couldn't move. Records showed proper sedation. But researchers found certain patients' brains showed continuous observation patterns, neurons firing in ways suggesting awareness monitoring itself, unable to shut down even under chemical suppression. The medical community called it anesthetic awareness, but it might be the quantum Zeno effect, consciousness observing itself so continuously it cannot transition to non-observation. Unlike quantum immortality, the Zeno effect is interpretation independent. It happens regardless of which quantum mechanics version you prefer. By being conscious, you might constantly measure your existence in a way that prevents transition to non-existence. Your awareness pins your quantum state in aware configuration. You can't stop observing yourself. Even in sleep, neural observation persists. The only way to stop observing is to stop being the observer. But the Zeno effect suggests continuous observation prevents that transition. It's a quantum catch-22. Being conscious might be the mechanism that makes unconsciousness impossible to experience. Right now, you're observing yourself reading this. And that observation might be the only thing preventing you from stopping. Russian roulette in every universe. Imagine quantum Russian roulette. In most universes, your friends watch you perish. But in your subjective experience, you pull the trigger 6 times and it misfires every time. You walk away confused. From your perspective, you're lucky. From quantum mechanics perspective, you just experienced quantum immortality. Traditional Russian roulette, 1 bullet, 6 chambers. 1 in 6 chances. Now modify it with quantum randomness. Wire the trigger to measure particle spin. Perfect 50-50 odds. Quantum events create branches. When you pull that trigger, the universe splits. One branch fires, another doesn't. Only one contains a you that continues observing. Pull once. From outside, 50% chance you're gone. From your perspective, you only experience the click. Pull 6 times. 64 branches exist. You're in the single branch where all 6 failed. Probability, 1 in 64. Observers are astonished, but you're just confused. Scale this to your life. Every moment contains quantum events that could end consciousness. Aneurysms depend on molecular scale weaknesses. Heart attacks on quantum chemical reactions. Accidents on timing relying on quantum uncertainty. In most branches, you don't survive all these, but your experience only follows branches where you continue. You're always in the timeline where the gun clicks, but everyone else isn't protected. You watch friends perish. You watch family succumb while you inexplicably survive. You become a statistical outlier. The crash survivor. The patient whose terminal diagnosis was resolved. From outside, you're lucky. From inside, you're trapped in the only timeline your consciousness can access. Russian roulette with quantum mechanics just ensures you only pull the trigger in universes where the chamber was empty, and that describes your entire existence. But these aren't just thought experiments. Your identity might already be fracturing. The split-brain patients who became 2 people. In the 1960s, surgeons cut the corpus callosum to treat epilepsy. The operations worked. But researchers discovered something horrifying. Patients had become 2 separate conscious entities sharing one body. If consciousness splits surgically, what does quantum branching do to who you are? The corpus callosum is 200 million nerve fibers connecting brain hemispheres. For epilepsy patients, cutting prevents seizures from spreading. Patients recover well and seem unchanged. Then Roger Sperry and Michael Gazzaniga tested them. They'd show the patient's left visual field an object. Ask what they saw. The patient said nothing. The left hemisphere controlling speech didn't see it, but ask them to use their left hand to pick it up, they'd grab it perfectly. The right hemisphere saw it and acted while the speaking hemisphere insisted nothing was there. In one case, researchers showed different images to each hemisphere. Left saw a chicken claw, right saw snow. When asked to point to related images, the right hand pointed to chicken. My left hand pointed to the shovel. Asked why, the left hemisphere confabulated, "You need a shovel to clean the chicken shed." It created false coherence for behavior it didn't understand. Other cases, one hand buttoning while the other unbuttoned. One hand striking out while the other stopped it. Which one are you? These patients prove consciousness is divisible. Your unified self is 2 systems integrated so tightly the seam is invisible. Until it's cut, then you become 2. Now connect this to quantum branching. Every quantum event affecting your brain creates a branch, different neurons firing, different thoughts emerging. If many worlds is correct, you're fragmenting constantly. Split-brain patients show consciousness divides without quantum mechanics, but quantum branching is far more aggressive. Trillions of slightly different brain versions, each in different branches, each with separate consciousness streams. Which is the real you? There's no original. All branches are real. You're not preserved, you're shattered into countless parallel streams, each convinced it's the continuous version. Quantum immortality promises consciousness continues. But split-brain patients force us to ask, whose consciousness? When you might be billions of diverging streams trapped in survival branches, immortality becomes existential dissolution. You don't get preserved. You get multiplied until you loses meaning. You're not being preserved. You're being shattered. And it gets worse. What if you were never whole to begin with? Boltzmann brains, consciousness appearing in the void. Here's a prediction physicists desperately wish was wrong. Given enough time, random quantum fluctuations will spontaneously create a conscious brain in space's void, complete with false memories of a life that never happened. Statistically, there should be infinitely more Boltzmann brains than real evolved humans, which means you're probably one of them. Ludwig Boltzmann developed statistical mechanics in the late 1800s. His work is fundamental. It's also responsible for one of physics' most disturbing predictions. Boltzmann showed entropy always increases. But statistical mechanics says, given enough time, random fluctuations can temporarily decrease local entropy. Particles randomly bouncing will occasionally arrange into lower entropy configurations. Scale this up. In a sufficiently long-lived universe, fluctuations could arrange particles into complex structures: stars, planets, brains. A human brain could spontaneously fluctuate into existence in vacuum, complete with neurons producing conscious experience and memories. Here's the problem. It's far easier for fluctuations to create a single brain than an entire universe with evolution producing brains. If you're looking at probability, randomly assembled brains should vastly outnumber evolved brains. Given infinite time, the Boltzmann brain pathway produces far more conscious observers, which means statistically, if you're conscious, you're probably a Boltzmann brain. In 2015, a programmer created a simulation calculating Boltzmann brain probabilities. After 72 hours, it outputs, "You are most likely not real." He described feeling physically ill. He deleted the code and never ran it again, not because the math was wrong, because it was right. A Boltzmann brain could exist for a fraction of a second before dissipating. The memories would be random configurations, false records of a life that never happened. How would you know? You wouldn't. Your memories seem real. Your continuity feels authentic. A Boltzmann brain could fluctuate into existence with false memories of reading previous sentences. Physicists propose cosmological models to avoid Boltzmann brain domination. But the connection to quantum immortality is profound. Maybe you're not evolved consciousness continuing through branching. Maybe you're already a random fluctuation with false memories, and any evidence you gather could itself be part of the fluctuation. The universe, your reasoning, your reality, all could be false data in a momentary brain floating in nothingness. This sounds like a theory, until you meet people for whom it might already be happening. The observer effect. What if you are Schrödinger's cat? Everyone knows Schrödinger's cat, both alive and not until observed. But Schrödinger designed it to show how ridiculous quantum mechanics seemed. He never expected physicists to embrace it. Now consider, you're not the observer opening the box. You're the cat inside, and you never experience the branch where you've ceased to exist. Schrödinger proposed this in 1935, furious at the Copenhagen interpretation, claiming particles exist in superposition until measured. To demonstrate the absurdity, he proposed, seal a cat with poison, a radioactive atom, and a detector. If the atom decays, it ends the cat. Quantum mechanics says the atom is decayed and not decayed simultaneously until measured. According to Copenhagen, the cat is both alive and not until someone opens the box. Schrödinger intended mockery, but physicists embraced it. Schrödinger's cat became quantum superposition's most famous illustration. Here's where quantum immortality enters. Nearly every discussion takes the external observer's perspective. But flip it, you're the cat. From outside, the wave function is in superposition. From the cat's perspective, the cat always knows its state. It's not in superposition from its own reference frame. If many worlds is correct, the universe splits when the atom decays or doesn't. External observers end up in one branch or another. But the cat's consciousness only continues where the poison didn't release. From the cat's perspective, the atom never decayed. This is quantum immortality from inside the box. You're the cat, and you only experience outcomes compatible with continued experience. Schrödinger died in 1961, frustrated his cat was adopted by the framework he designed it to criticize. But his thought experiment had sharper teeth than intended. He gave us the perfect quantum immortality metaphor while trying to prove absurdity. You're in the box right now. You've always been in the box. And from your perspective, the atom never decays. You just keep existing in the branch where you're there to realize you're trapped. The universe, as usual, has a notoriously dark sense of humor. The near-death survivors who shouldn't exist, Frain Selak, survived a train crash, plane crash, bus crash, car explosion, 2 car accidents where he was ejected, and then won the lottery. Doctors who reviewed his case don't use lucky. They use statistically impossible and quantum outlier. What if some people are already living proof? In 1962, Selak's train derailed into an icy river. 17 perished. Selak survived with a broken arm. Next year, plane door blew off mid-flight. 19 went down. Selak was thrown out but landed in a haystack, alive. 1966, bus skidded into river. 4 didn't make it. Selak swam to shore. 1970, car caught fire, escaped before fuel tank exploded. 1970, 3, another car fire. Hair singed off, survived. 1995, hit by bus. Minor injuries. 1996, crashed through guardrail, ejected from car. The vehicle plummeted 300 feet and exploded. Selak grabbed a tree branch. Then in 2003, he won $600,000 in the lottery. Compare to Tsutomu Yamaguchi, in Hiroshima, when the first atomic bomb detonated, survived. I returned home to Nagasaki. 3 days later, the second bomb fell, less than 2 miles from ground zero. Survived both. Lived to 93. Or Vesna Vulovic, her plane exploded at 33,000 feet in 1972, found strapped to her seat in wreckage. Guinness certified it as the highest fall survived without a parachute. These are documented cases with medical records. They shouldn't exist. Surviving 7 catastrophic accidents? Probabilities make winning the lottery look common. And Selak did that too. From a classical perspective, they're fortunate. From quantum immortality's perspective, they're observers trapped in low-probability branches. In most branches, Selak ceased to exist in 1962. But his consciousness only continued where he survived. Each survival funnels into narrower probability spaces. These extreme cases might not be proof. But they're exactly what you'd expect to see if quantum immortality were real, repeated, improbable survival while everyone around follows normal probability. Selak and others aren't proof, but they're what quantum immortality looks like from inside. And if they're experiencing it, what makes you think you're not? Heat death and the eternity problem. The universe will eventually cease to exist in any meaningful sense. In 10 to the 100th power years, all stars will burn out, all black holes evaporate, reaching heat death maximum entropy, nothing happening forever. Traditional physics says consciousness ends with your brain. Quantum immortality says you continue experiencing something, even after the universe ends, possibly forever, in darkness, alone, aware. Stars will form for another trillion years, then stop. By 10 to the 14th power years, all stars exhaust their hydrogen. The universe goes dark except for dim brown dwarfs and white dwarfs cooling. Black holes slowly evaporate through Hawking radiation. A solar mass black hole takes 10 to the 67th power years. Supermassive black holes take 10 to the 100th power years. When the last evaporates, the universe reaches maximum entropy. No structure, no change. This is heat death. A static wasteland where nothing meaningful occurs again. Now apply quantum immortality. Your consciousness continues down branches where you exist. But what does that mean at heat death? Your physical brain will have ceased long before. So what remains? According to some interpretations, consciousness becomes the persistent observer, not tied to physical substrate, but to subjective experience continuity through quantum branching. You might find yourself as disembodied awareness in a universe with nothing left to be aware of. The only events in a heat-death universe are quantum fluctuations. Remember Boltzmann brains? Random fluctuations create temporary entropy pockets. These could include conscious experiences, moments of awareness with false memories appearing randomly across eons. If quantum immortality is real, your consciousness might persist by hopping between fluctuations. A moment here, eons of nothing, another fluctuation. Not continuous existence, but sporadic flickers separated by incomprehensible time. Heat death isn't an ending, it's a plateau. The universe at maximum entropy continues indefinitely, forever. Some physicists search for escape hatches. Roger Penrose proposed cyclical cosmology. Others suggest quantum tunneling might trigger a new Big Bang. But these are hopes. Current evidence suggests heat death is inevitable and permanent. Traditional endings provide mercy. Your brain stops, you stop. But quantum immortality denies that release. It traps awareness in the eternal present, forced to observe even when there's nothing left. This is the final implication terrifying physicists. Not just that you might survive accidents, but that you're cosmically trapped in consciousness itself. The universe can end while you continue. Every star burns out, every black hole evaporates, every structure dissolves, and still something identifying as you persists. The universe might be indifferent, but quantum mechanics might be cruel. It gives consciousness, then refuses to let it end. And if many worlds is correct, if the quantum Zeno effect applies to awareness, if consciousness really can't stop observing itself, then heat death isn't an ending. It's just when you realize you've been immortal all along. Remember Moravec, the physicist who stopped talking about quantum immortality at dinner parties? He was asked why it bothered him. His answer was devastating. Because every time I pull into my driveway and survive another day, I have to wonder in how many branches did I not make it home? And how many am I the last one left, arriving at an empty house, unable to understand why everyone else aged and perished while I'm still here? You've survived every moment of your life so far. Every accident avoided, every illness recovered from, every close call. From your perspective, you always make it through. Maybe that's luck. Or maybe you're already experiencing quantum immortality, funneled into the narrowest probability branch where you're still here to wonder. The disturbing part isn't that it might be true. The disturbing part is you'd never know the difference. You only experience the timeline where you survive long enough to doubt it. And somewhere, in branches you can't observe, other versions aren't wandering. They know. Because for them, it already ended. But not for you. Never for you. You're Schrödinger's cat, and the poison never releases. You're the Russian roulette player, and the gun always clicks. You're Frain Selak walking away from the seventh accident. Your consciousness is trapped by the quantum Zeno effect, unable to stop observing. You're a fragment of Everett's splitting universes. You might even be a Boltzmann brain with false memories. And when the universe reaches heat death, when every star has burned out, and every structure dissolved, you might still be there, aware, alone, forever. Sweet dreams. If that kept you up at night, hit subscribe, because quantum mechanics has more existential nightmares where that came from. And if you made it this far without clicking away, you're either fascinated or trapped in a probability branch where you have to finish videos. Either way, leave a like so I know which timeline I'm in.